Hi, this is Mrs. Kidman, and in this video, we're going to be talking about an n-gon. So an n-gon just represents a polygon with n number of sides. Now that n could be 3 sides, making it a triangle, or it could be 12 sides, making it a dodecagon. We don't really care which it is, but really what we're trying to do here is we want to write down some general ways that we can figure out how many sides, angles, the sum of their interior angles, and the measure of one interior angle might be. Now, when we're talking about an n-gon in this case, I am going to be talking about a regular polygon for the sake of the measure of one interior angle. But remember that the sum of interior angles, this is going to apply to any polygon with n sides. Okay, so that'll work for any of them. So an n-gon, when we're talking about it, it has n number of sides, where n is greater than or equal to 3. It's also going to have n angles. Now, when it comes to the sum of the interior angles, in the previous video, we kind of did an exploration discovery in which we were looking at that relationship between the sum of the interior angles and the number of angles and sides and how we can kind of figure that out. And so after that discovery, hopefully you found a chance to derive something for yourself. But ultimately what I discovered is the sum of the interior angles is going to be the number of sides minus 2 times 180. And once we have that, we can use that over and over regardless of what it is. Now, if that's a regular polygon, what we figured out is that you can take that n minus 2 times 180 and actually divide it by the number of sides that we have. And once we divide it by that number of sides, we can figure out what one of those angles is going to be. Now, that's super helpful when it comes to looking at any interior angle. We can always find what that would be using these two general terms. And these general phrases here are actually called, this one is actually called the polygon interior angles theorem, is what it says. We proved it as we looked through that pattern and saw what happened. We kind of found that pattern there. It also has a corollary about it relating to quadrilaterals and stuff like that. Remember, corollary is just like a little theorem associated with the big one. So another theorem that is really cool about angles of polygons is, in this case, we're talking about interior angles. So here's that beautiful poorly drawn hexagon again that we see. Now, when we talk about these interior angles, what we're talking about is these angles on the inside of our polygon here. Okay, what we also want to talk about is what's the relationship between the ones on the outside of our polygon. And this is actually so cool. So the exterior angle theorem says that the sum of the exterior angles of a convex polygon, so remember, a convex one is one where it all comes out. It does not ever come in. So it's not like this, it's going to look like this. One angle, if it only has one angle at each of the vertices, the sum of all those exterior angles is going to be 360 degrees. How cool is that? And so here's kind of a picture example of what happens there. So here is a pentagon here. We can see that it has 5 sides. And what they've done is they've shaded one of the exterior angles. No, not both of them, just one of them. And when we talk about an exterior angle of a polygon, so let me draw a bigger hexagon here. What we're talking about is if I were to extend out all of the sides here, the exterior angles of a polygon are actually going to be those angles that we see here, but not the whole thing. So it's just going to be this little piece that makes it a linear pair. So we would have this angle here. When we look at this piece, we might either have this one, which is, or this one right here, which is a linear pair with this one. This one, I'm going to use this angle right here. We can use this angle, this angle, this angle, this angle. It's pretty cool. So then theoretically, if we were to like cut out and take each of those angles and put them together, it would make a circle. Isn't that so awesome? And so the sum of those exterior angles will always equal 180 degrees, which is super cool. Okay, so what we are going to do is we're going to apply this exterior angles theorem here. So this says, let's solve for x. So what do we know by that? So what do we have here? Well, I have 4 exterior angles. And what do I know about exterior angles? Well, if it's convex, which in the case this one is, they're going to add up to 360. So let's go ahead and do that. I know that 2x plus x plus 89 plus 67 is going to be 360 degrees. So then let's go ahead and combine these. 2x plus x is 3x. 89 plus 67 is going to give us 156, and that equals 360. And then lastly, we want to solve for that x, so we're going to subtract 156 from both sides, and we end up getting 204 equals 3x, and then we can divide by 3 on both sides, and we end up getting that x equals 68 degrees, right? So this little angle here is 68 degrees. Isn't that super cool? Wow, I just love some of these geometry theorems because they're so great. So let's go ahead and apply both our interior angle, some of our interior angle theorem and the sum of our exterior angle theorem to figure out some angles here. So this next problem here has a trampoline that's shaped like a regular dodecagon. Now remember, a regular dodecagon means that all of the angles inside are going to be the same. So dodecagon has 12 sides. That's what that dodecagon means. So that means we've got all 12 of these sides here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we want to know what this angle is. We also want to know, if I continue this on, what is this angle going to be? So we want to figure out those two things. Now, starting with part A, where we want to find the measure of each interior angle, what we're going to do is we're going to initially start by using that sum of the interior angles theorem. And that's going to be the number of sides minus 2 times 180. And so our number of sides here is 12. So we've got 12 minus 2 times 180, which is 10 times 180, or 1,800. Now with this 1,800, because we want to find the one of each interior angle, knowing that it's regular, that means each of those interior angles are the same. So I'm actually going to divide that by 12. And when I divide that by 12, I end up getting 150 degrees. So the measure of each interior angle of this dodecagon is 150 degrees. Now let's look at part B. So we want to find the measure of each of the exterior angles. Now, because we know that this is a regular polygon, what that means is that if each of the interior angles is one thing, each of the exterior angles is going to be another. Now, using that theorem, we know that we have 360 degrees total on the outside, and there are 12 angles. So if I divide it by 12, what I'm going to get is 30 degrees. Now, that's one thing to keep in mind. The other thing that is so cool about this, I'm going to use orange, is here's this line here, and here's the edge of our shape. Notice how right here, when we create this extended line off that side, we've created a linear pair. So if our inside angle here is going to be 150, this angle, so angle B, plus 150 have to equal a linear pair, or 180. So the other way to find that with a regular polygon is actually to do 180 degrees minus the sum of the interior angle, which is 150 degrees, to get 30 degrees. Isn't that awesome? So it's super cool there, the way that we can do that. Now, the very last thing that I want to do is I want to write a formula that will help us kind of going the other way. So we're going to write two. One is writing a formula for the number of sides of a regular polygon if we're given the measure of the interior angle. So what that means is, say we were given the interior measure of 60, how do I know that it has 3 sides? Well, what I'm going to start with is, what is an equation for the measure of the interior angle? Well, we know the sum is 180 times n minus 2, right? Or n minus 2 times 180. Now, to find the measure of the interior angle, we are going to divide it by n. And that is going to equal that measure of the interior angle. So if we're given that, how can I figure out what n is? So that's kind of what I'm going to solve here, is I want to find what is n. So we've got a couple of different things that we can do here. As we divide it, one thing I want to do is I'm going to do 180 times n minus 2 equals m times n, right? Because we know that. And then I'm going to multiply this out. So 180n minus 360 equals m times n. And then we actually can divide both sides by n. We can subtract this. So we get negative 360 equals m times n minus 180n. And notice how they both have an n here. So what we're going to do is actually factor that out, and I get n times n minus 180 equals negative 360. And then we can divide both sides by that m minus 180. So to figure out the number of sides, if they give us the interior angle, what we can do is actually take negative 360 divided by m minus 180. Okay, we also can switch the signs on these, and we can do n equals 360 divided by 180 minus m. And this is the more common expression that you're going to see. But isn't that awesome that we have this formula here that we can use for that? Now, the other thing that we want to do is use the formula for the number of, find a formula for the number of sides of a regular polygon given the measure of the exterior angles. So the measure of the exterior angle, remember, when we're talking about this, before that was just m. In this case, this is going to be 180 degrees minus m is what that's going to equal. So we've got 180 times n minus 2 over n equals 180 minus m. Now this plays a big role here because then that'll adjust our problem a little bit. We're going to multiply both sides by n, so I get 180n minus 2 equals 180n minus m times n. And then I'm going to distribute this out, so I get 180n minus 360 equals 180n equals 180n minus m times n. And then what we can do here is we can actually subtract this 180n from both sides. And this is where it gets cool. So then we end up getting negative 360 equals, these cancel out, negative m times n. And then I want to get n all by itself, so I'm going to divide both sides by negative m. And what we end up getting is 360 divided by m equals n. So if we want to find the number of sides, if we're given the measure of the exterior angle, what we do is we just take 360, divide it by that measure of the exterior angle, and bam, we've got our number of sides. Isn't that so cool that we can just manipulate that? I love manipulating equations to find those patterns. So these are some really cool things that we can figure out with the angles of polygons. If you have any questions, feel free to reach out. But remember, two of the most important things here are that formula for the sum of the interior angles of any polygon is the number of sides minus 2 times 180. The exterior angles will always add up to 360. And so because of that, we can actually write different formulas to either find the number of sides when we're given the measure of one interior angle of a regular polygon, or find the number of sides of a regular polygon when we're given the measure of the exterior angle. How cool is that? If you have questions, feel free to reach out.